All right, we're going to go over these examples real quick just so I know that y'all have a good basis to work with. So we're going to write the component form of the following vectors using the given information. These are two different examples. We'll start with this one. This one's pretty simple. All we got to do is, since it's graphed, we can count the units that it travels horizontally, and that'll be our x value, and we'll count the units that it travels vertically, and that will be our y value. So when we write component form, we know that we're going to have these little pointy parentheses, and like I said, sorry, I think some snow just fell and hit the window. Anyway, like I said, we're going to count the units that the vector travels horizontally, and in this case, it's going to be 1, 2, 3, and it's going to the left from H to G, and we always read from the point to the arrow, okay? So as you can see, there's the arrow by G, so that means we're going to go from H to G, and when we go from H to G, we travel 3 backwards, so that's going to be -3. We can put that up here. And when we travel from H to G, we go 1, 2, 3, 4, 5 units upward. 1, 2, 3, 4, 5. And that's going to be positive because we move up. And so our component form of vector HG is simply going to be -3, 5. So let's think about this when we don't have a graph. So what we really did when we counted these units, we really subtracted H from G, right? So we took away 3 units, or took away -3 units from G, which ends up being adding 3 units. So we started at G, right? And then we subtracted H. So if we start, or if we have vector Mn, so that would look like this. And the arrow is over the n, so the arrow would be similar to this. The arrow would be right next to the n. So we're going to go from n, or we're going to go from m to n. Well, we can't count units, so what we can do is, like I said, we're going to subtract the initial point from the end point. So what we're going to do is the initial point, or the end point, is 2, -7. So we're going to go 2 and -7. We're going to subtract the initial point, and the initial point is -8. And the initial point for the y values is going to be 1. And so that would make our x, or that means that our x traveled from -8. So let's picture a number line, right? So here's 0, here's -8, here's 2. So what this is doing when we subtract -8 from 2 is it's counting this whole area. So 2 minus -8 is going to be 2 plus 8, which is 10. And we can see that if we travel from -8, which is where this one starts, right, all the way to 2, which is where this one ends, we can see that it would be 10 units long. So that's what this subtraction is doing. It's finding the difference between these 2 points. And yeah, so this is a visual way to represent this. And similarly, if we have a number line going up and down, we would start at 1, and we would go down to -7. So if we start at 1 and go down to -7, we would go 1, 0, -1, -2, -3, -4, -5, -6, -7. And so the difference in that is going to be down 8, represented by the -8. And so since we just counted these with subtraction, we know that this is the horizontal distance traveled, right? And this is the vertical distance traveled, and we said it was 8 downward. Our component form of this vector then would be 10, -8. So hopefully that makes sense. Definitely bring in questions to class if you have questions about that. And just for the last examples here, we're going to find the magnitude of the following vectors. So this is kind of different because we have to find the magnitude or the length of the vectors given component form or given component form. So this is kind of interesting. But what we can think about is taking our prior knowledge, drawing some pictures, taking what we know about these vectors, and we're going to piece a formula together ourselves that will let us calculate the magnitude. So if we have a vector that goes left 1 and up 5, let's draw that out. So it goes left 1, up 1, 2, 3, 4, 5. I'll draw that a little bigger. So it goes left 1, up 1, 2, 3, 4, 5. So we've got this vector right here. So if we know that we went left 1 and up 5, why don't we just say this? Why don't we say that this is 1 and this is 5? And we know that we're working with horizontal and vertical shifts. And so the angle between the horizontal and the vertical shifts is going to be a right angle. And what do we know? What did we just learn? What did we just learn about right triangles and ratios between sides and angles? We learned a bunch of stuff about it, right? Frankly, we don't need to use any angle measures in this, but we have another trick up our sleeve that we can use. So something that you'll know for the rest of your life is how to find this distance here, right? If we have A, B, and C, we know that we can find C, the hypotenuse, by doing A squared plus B squared equals C squared. You don't have to write this out, I'm just explaining this. Right? And so if we just wanted C, if we wanted C by itself, what we could do to this algebraic equation is take the square root of both sides. And we would end up with C equals the square root of A squared plus B squared. Just like that. And this is for right triangles, right? But there's not anything specific that has to be the case with side length A or B. So why don't we just take this property and move it over here, right? So if we're trying to find the distance CD, we can name that X. And why don't we just say that X squared, this is the Pythagorean theorem again, right? X squared equals 1 squared plus 5 squared, or negative 1 squared, sorry. Or more specifically, we could say that X equals the square root of negative 1 squared plus 5 squared. That looks kind of rough, but this is X is the square root of negative 1 squared plus 5 squared, because that's our X value and our Y value of distance. So what this gives us is 1 squared is 1, 5 squared is 25, or negative 1 squared is 1, sorry, misspoke. And so if we take the square root of that, we don't end up with a pretty number, but we can leave it in the radical form, and we just get the X. So the magnitude of CD is the square root of 26. So why don't y'all try a similar method for finding HG, and we'll take those answers into class, and we'll discuss this method and this formula and finding magnitudes of vectors next time.